Hello, and thank you for joining us for the third and final day of the Sydney Dialogues November program. Wherever you're watching from around the world, let me extend a warm welcome from the summit's organisers, the Australian Strategic Policy Institute. The theme for our first session today is collaboration in the new age of space. I'd like to remind everyone that you can join our public conversation on Twitter by using the hashtag TSD2021, and I hope you all enjoy the session. Hello, and thank you for joining us for the third and final day of the Sydney Dialogues November program. Wherever you're watching from around the world, let me extend a warm welcome from the summit's organisers, the Australian Strategic Policy Institute. I'm also pleased to announce that this session will be streamed as part of the Bengaluru Tech Summit, Asia's largest technology event. The theme for our first session today is collaboration in the new age of space. It's a great honour to be speaking with such an eminent panel today. Thank you all for being here. We have representatives from the space agencies of each Quad country: Japan, India, Australia, and the United States. Let me start by introducing our panel. First, we have Pam Melroy, Deputy Administrator at NASA. Deputy Melroy was selected as an astronaut candidate by NASA in 1994. As second in charge of NASA, Deputy Melroy is responsible for laying the agency's vision and representing NASA to the Executive Office of the President. She is one of only 2 women to have commanded a space shuttle and has logged more than 38 days in space. Next, we have Dr. Hiroshi Yamakawa, President of Japan's Aerospace Exploration Agency. President Yamakawa was appointed as President of JAXA in 2018. During his time at JAXA, he has worked on the design of Earth-orbiting scientific satellite projects, lunar missions, and interplanetary missions. Prior to joining JAXA, Dr. Yamakawa served as a Cabinet Secretary in the Japanese government. And also joining us is Enrico Palermo, head of the Australian Space Agency. Before joining ASA in 2021, Mr. Palermo spent the previous 14 years in various roles at Virgin Galactic, including in its main business and manufacturing subsidiary, the Spaceship Company. He was part of the team that delivered Virgin Galactic's public listing on the New York Stock Exchange in 2019. Finally, we have Dr. Kailasavadivoo Sivan, Chairman and Secretary of the Indian Space Research Organisation. Chairman Sivan joined ISRO in 1982 to participate in the Polar Satellite Launch Vehicle project. In July 2019, under Chairman Sivan's leadership, ISRO launched India's second lunar exploration mission, developed to map and study the variations in lunar surface composition and the location and abundance of lunar water. Thank you all so much for joining us. It's an honour to have you here today. Let's kick off with a question for Deputy Melroy. So, space has undergone something of a renaissance recently. What factors are driving this renaissance?
Well, thank you, Ray. It's such a pleasure to be here, and especially to be on this panel with my cherished colleagues. And I'm really appreciative of the conversation that I know that we're going to have. So there are multiple factors, but I think we can safely say that government investment has been the engine that has driven the commercial space renaissance. The technologies that have been developed by government, and I think NASA can safely take credit for that, but also the investments and the partnerships to bring commercial space forward have been incredibly important. I think we can also say that the technology revolution that came with Moore's Law, which is well known in the microelectronics world, to say that the size of microelectronics shrinks, of course, our Cell phones are just a visible representation of that, but the ability to pack more capability into a smaller space has had a big impact on small satellites. The smaller things are, the less they cost to launch. Lower cost access to space has also contributed. And I think, I look back at the commercial cargo program that NASA started more than a decade ago to facilitate low-cost access to space to carry cargo to the space station, sort of kicked off a cycle, and a lot of new capabilities have been developed in the last decade.
Wonderful. Dr. Yamakawa, there is a lot of discussion around increasing cooperation in space. What are some of the big projects you believe could galvanise global cooperation in space?
Well, thank you very much, Ray. First of all, I would like to say that it's a great pleasure and honor to be part of this wonderful panel. Well, first of all, we have, today we are a panel of 4, and from 4 countries of Quad. And I understand the 4 countries of Japan, the United States, Australia, and India are partners with shared and fundamental values, working together to strengthen a free and open international order based on the rule of law. And I hope that these partners sharing a set of common values will jointly expand the scope of our space exploration activities, including lunar exploration. And I have to say that, well, international collaboration is vital for every space mission. And for example, the International Space Station is a great endeavor which enables humankind to be in space for more than 20 years consecutively. And this is a great example of what we have done together. And for example, JAXA has collaborated with Australia in Hayabusa 2 mission, which is a sample return mission from the asteroid Ryugu. And collaboration with Australia made it possible to actually recover samples back to the Earth last year. It was a great achievement based on international collaboration. And together with India, we are currently planning a joint mission to the moon, which we call Lunar Polar Exploration Mission. And we will provide a rover, and India will provide a lander. So that is a great joint project between us. And within the United States, it is not possible to cover everything in just several minutes, but one example is the ISS, and another great example is the Artemis program. And we are going to collaborate with not only with the United States, but many countries in the near future, lunar exploration. And we will provide habitation function to the Gateway, which is a new manned space station around the moon or in the vicinity of the moon. And also we will provide cargo transportation capability using our own space cargo ship. And also we will collaborate with the United States in terms of the near future, a sustainable exploration, not only in the vicinity of the moon, but also on the surface of the moon.
Chairman Sivan, what is ISRO's view on the scientific and technological possibilities regarding crewed missions to the moon and to Mars?
Let's first consider the aspect of moon mission. Apart from the science of the moon, the potential aspect of the crewed lunar mission is science from the moon, wherein radio astronomy receivers may be deployed and operated in the relatively RF-free far side of the moon. Moon also will serve as a potential observatory, as there is practically no atmosphere that would have affected the signals from the space. Moon can also be used as an observatory to study the Earth, especially to study the IR signatures of global warming, emissions from atoms, to study the precipitation of high energy charged particles, along with Earth's magnetic cusp, to name a few. Now coming to Mars, one potential area is terraforming. A capsule may be sent to Mars, which may be initially aided by human astronauts, which will be kept isolated from the Martian environment. Terraforming of that restricted zone may be taken as a model which may be scaled up in future. Human intervention will add extra dimension to the problems of searching biosignatures on Mars. Another area of research is in situ resource utilization, ISRU, where the astronauts may demonstrate the process of vacuum pyrolysis on Moon and Sabatier process on Mars to generate propulsion using local resources. The dexterity of human astronauts may be required to demonstrate the experiment in a smaller scale. Once that is successful, the next step would be to scale it up and automate the process with suitable mechanisms.
Some exciting projects underway there. I can't wait to see them come together. Now, in terms of a big collaborative project, how might the Quad members work together to develop new spacecraft and propulsion technologies to make getting to Mars in the 2030s and beyond, making that cheaper and safer and quicker? Mr. Palermo.
Thank you, Rae. And I'd also like to extend and thank the Sydney Dialogue for allowing me to be on this panel, wonderful panel with our esteemed colleagues at the heads of and deputy heads of our partner agencies. The opportunity, I think, to collaborate from the Quad on missions like you just outlined, I think are really immense, and it's going to build off, I think, early steps that our partners, and Dr. Yamakawa just summarised a few, for example, Hayabusa 2. What are these initial projects that allow us to build together towards a vision to the Moon, the Mars and beyond? And I think, I definitely commend NASA for the vision of Artemis, and it's very open arms, I think Colonel Melroy would say, to the world to come on that journey of Artemis, and that is something Australia is very interested in doing, and we were proud to announce recently, obviously, our first step with the rover partnership on the surface of the Moon. And so the Quad, it's written into its charter and some of the recent statements to increase collaboration in space. And so we have the Space Working Group coming together. So what we're putting in place is the mechanisms that will allow us to design programs to identify not necessarily gaps, but opportunities in the architecture where we can bring our respective competitive strengths and opportunities. And in Australia, we're very excited to, as a relatively new space agency, but a long heritage in deep space communications, remote operations, space medicine, life sciences. We see an opportunity to sort of work with Quad partners collaboratively on where architecture can add up to longer term missions.
Absolutely. Would a multinational mission to Mars led by the Quad members be the best approach to getting humans on the Red Planet, especially given the cost of such an endeavour? Dr. Yamakawa.
Well, thank you very much for the great question. First of all, I would like to introduce JAXA's activity toward Mars. And based on the technology and experience gained through the Hayabusa series sample return mission to the asteroids, we aim to return samples from the Martian satellite Phobos in 2029 through the Martian Moons Exploration Mission, which we call MMX. And through this MMX mission, we aim to develop technologies for Earth to Mars transit and also advanced sampling techniques on the surface of celestial bodies. And I think future missions to Mars are expected to be a combination of manned and unmanned robotic missions. So we believe that the technology based in the MMX mission will be valuable, especially these kind of technologies will be indispensable for future manned mission to Mars. And as I said, another example of large-scale space joint project is the International Space Station Program. And such kind of large-scale projects, including the future Mars mission, requires enormous financial resources, as as was dictated by in your question. And so rather than implementing it alone, a more realistic approach would be to promote it through a multilateral international cooperation, with each country contributing with its own technical field of expertise and sharing the costs. I think that's the basic way to approach.
Yeah, a very practical way to approach it. Makes a lot of sense. Now, there has been a lot of criticism of space billionaires like Elon Musk and Jeff Bezos and Richard Branson recently. A common argument is that they should be directing their wealth to solving problems on Earth rather than promoting joy flights, essentially, to near Earth for the rich. Is this argument short-sighted, ignoring the long-term benefits of developing lower-cost access to space, or is it valid criticism? Deputy Melroy.
Yes, I have definitely heard this, and I think it's, I mean, to me, I think we just need to see the fact that commercial space is in a renaissance, and there are great benefits that are occurring here on Earth as a result of that. And that is very important to understand, that we go to space to benefit life on Earth. One individual flight by an individual, that's not actually why those billionaires did it, although they have that opportunity. Really, the investment is there for the long-term potential. I think, my view on it is that, for example, if we look at the existential crisis of our time, which is climate change, the ability to measure and monitor the Earth is actually best done from space. And so increasing access, and we're seeing it now in our Earth Science program, that is the fastest growing area that we're leveraging commercial space capabilities. So those things are happening because of lower cost access to space and those investments. I think there's room in this world for a lot of problems to solve. And I, for one, am grateful that there are people who choose to spend their effort on something that I can see a direct line of sight towards climate change.
It would be difficult to not, if you could, as well. I can imagine that if I had the funds and the means and all of the materials available to me to be able to go to space, I would absolutely be in space right now. So what are some of the benefits, though, that private sector space actors are creating for the space sector as a whole? Dr. Yamakawa?
Well, thank you very much for your question. Well, I think traditionally space activities have been carried out mainly by space agencies of various countries till now. But in recent years, well, recent means about 10 years, activities by individual players, mainly in low Earth orbit, have been increasing. And in addition, the activities of new space, a new player in space activities, are also gaining momentum. And well, particularly in the United States, private companies are providing services to support the activities of space agencies in human space transportation. And we believe that the development of a wide range of space business by the private sector will further lower the barriers to space and contribute to the improvement of human life and increased convenience. And in the midst of these developments, seeing that ordinary people, in addition to professional astronauts, are now going into space, I feel that a major trend is emerging, that is expanding the sphere of human activity and eventually improving the life on the Earth. I mean, as discussed by Pam, by lowering the barriers to space or increasing the access to space, that will create new services on the ground, I mean, on the surface of the Earth, and improve life on the Earth. So that is my understanding of the current situation.
A question for you, Chairman Sivan. Space agencies across the globe are investing time and money developing their own capabilities for space exploration. Many of them are joining hands in this endeavour through international cooperation. Do you think human spaceflight is a good candidate for international cooperation?
India has initiated the human space flight program named Gaganyaan, recently announced by the Honorable Prime Minister of India in 2018. Since then, the major thrust area of ISRO's international cooperation has been the human space flight. ISRO is engaging with many of the spacefaring nations in this particular field. The Indian astronaut candidates have completed the Russian leg of their training at Gagarin Cosmonaut Training Center. We are cooperating with CNES, France on space medicine, with Canada and Romania on internal testing, and with Australia and ESA on ground station support. The present Gaganyaan program is the stepping stone for establishing a sustained Indian human presence in outer space. So I am sure that the present cooperation will continue and it will lead to increased engagements with international partners in the times to come.
Absolutely. Deputy Melroy, what are your thoughts on commercial actors undertaking mining on the moon? How should that be managed when these companies can claim a resource under the 2015 Space Resources Act, but cannot claim territory under the 1967 Outer Space Treaty?
Right. We have all of us, we have some work to do. I think that's one reason why we think the Artemis Accords is incredibly important as we go out and begin exploration. And the Artemis Accords were the intent to open a dialogue and share our views on what we think is are the values that we want to take out into space. Of course, the Outer Space Treaty is a series of principles. Each country has been able to interpret those principles into their own space laws. I think, we recognize that we'll all have slightly different views on some of these subjects, but in the near term, as Hiroshi brought up, that in the past it's been about governments, and I think in exploration we're going to see that for a while. Although we want to pave the way for opportunities like commercial space transportation, I think the Artemis Accords at least begin to come up with some thoughts about how government oversight activities in those areas could be viewed, and we hope that the private sector will follow suit and fall in line. It's very important that we consider sustainability as we go forward into resource extraction, and that's certainly a value that we've articulated.
So, Mr. Palermo, some states, notably Australia, have signed the 1979 Moon Treaty, which further constrains opportunities to use lunar resources. As private exploitation of space resources increases, how will this be resolved, and will Australia be left behind?
That's right, Ray. Australia signed the what's known as the Moon Agreement in 1986, and we are one of the only states that are a party to the Artemis Accords, and we're proud to be a founding signatory to the Artemis Accords and the Moon Agreement. And that's because we believe and we think it's appropriate to do that, and that the Artemis Accords is not in conflict with either the Moon Agreement or the Outer Space Treaty. And if you look at the Moon Agreement, it echoes many of the provisions of the Outer Space Treaties, and actually allows states to do things such as collect and remove samples of the moon's natural resources, and also look at using resources as the Artemis Accords to sustain a presence. And that's a key part of the Artemis regime. So no, I don't think Australia will be left behind. In fact, I think we're in a unique position to have a moderate voice in the world to really step up and show leadership on how we can move from these principles that Colonel Melroy outlined into sort of practical implications and procedures and processes as we establish that human presence permanently on the moon and beyond. So our view is, the agreements were not inconsistent with what is intended, And we think Australia is in a unique position to show leadership in how we can move forward in some of these complex matters.
Absolutely. And Mr. Palermo, again, do the Artemis Accords provide a good pathway towards sustainable space resource utilisation in a way that is consistent with international legal obligations?
Yes, we do. Australia wouldn't have signed up if we felt the Artemis Accords were in conflict with our international obligations. And, one of the important things we're involved with, and I believe all the parties are on, is what's called the long-term sustainability of outer space. So we are a contributing partner to UN COPIUS. And what's really interesting is in the last year, there was a space working resources groups form. And so what we're going to move from, again, is from these principles to like specifics on how we do this. And we want to do it in a responsible way. It's a pillar of our agency. No, we don't see any inconsistency there.
And Deputy Melroy, a key ambition of Project Artemis is to return to the moon to stay, to establish ultimately a permanent human presence on the lunar surface. Later Artemis missions, including larger and more capable infrastructure on the surface and in lunar orbit, become possible to enable a larger human presence on the surface beyond the 2 astronauts planned for the early Artemis missions.
That's right, Ray. It's very important for us to have developed a capability to transport people, right? It's step number 1, and we're excited that our moon rocket, and the only vehicle currently capable of taking humans to the deep space environment, will be launching on its first test flight in February. It's going to be pretty exciting to see the first rocket going to the moon in 50 years. We're very excited about it. But I think one of the things that I'm excited about is all the other kinds of things. Getting there is absolutely critical, but you bring up a really important point about infrastructure. I think infrastructure is absolutely essential just to keep human presence, but it's also essential to develop businesses. There currently aren't good business models for the moon right now. But one of the things that we've seen is if we lay in infrastructure, and here on Earth that has to do with transportation, communications, even the internet, things like that, have enabled multiple businesses that could not have been forecast in the past. And so we think the same thing is true, and it's also a unique opportunity to partner with our international partners. And in fact, I have to say, I think resource extraction to get rocket fuel out of the water on the moon is a great example of the kind of infrastructure that would be very powerful. If you could have a fuel station on the moon, that would be incredibly enabling. And we've, of course, taken the first step in our partnership with Australia for a resource extraction rover demonstration. So we're starting out with some baby steps. What I think is most exciting about the discussion about infrastructure is, if you think about it, we are thinking about how to generate a blueprint for how we might recreate something like this on Mars. If we wanted a sustained human presence on Mars, we're going to have infrastructure there too. And so we are practicing. We are city planning, if you will, and trying to understand, what's the right way to do this. So I think the infrastructure sounds boring to people, but not to me, because I think about that as the blueprint for the future. And it's absolutely essential to go there with our partners.
Space infrastructure will never sound boring. That's impossible. I would like to now turn to some questions that have been submitted by our community of delegates. We've had some questions come through for the panel. And first up, we have a question from Dr. Malcolm Davis, Senior Analyst with ASPI. What's your 30-year vision for humanity in space? Elon Musk and Jeff Bezos talk about space colonisation, but is that viable? Is a more careful and cautious approach based around human and robotic exploration of the solar system and utilisation of space resources, is that more likely? Who would like to take this one? Dr. Yamakawa.
Well, I think our journey in space, in the future, largely depends on the knowledge obtained from the near future lunar exploration. Talking about Artemis program, such as water resources exploration, and it is necessary to appropriately proceed with the infrastructure development. Space infrastructure development to support such exploration in accordance with the development stage of the lunar activity. And the means of transportation which support lunar exploration are critical foundation from the early stages. And on top of that, unmanned construction systems, positioning systems like on the Earth, GPS system, but also communication systems and so on are likely to be needed as the exploration progresses. And if a sufficient amount of usable water resources is secured, facilities for utilizing the water resources will also be required. And furthermore, when lunar activities expand further, like when manned exploration begins at full scale, facilities for stay and storage, systems for power supply, systems for the use of local materials, and the reuse of resources brought in from the Earth might be required. And if the number of people staying there increases, food production systems would be required. So it's really creating a new infrastructure in space. And while envisioning such a future for the next 3 decades, I think it is important to steadily develop exploration activities step by step.
Thank you very much. Next up, we have a question from James Brown, who is the CEO of the Space Industry Association of Australia. James asks, how critical is space to the monitoring and management of climate change? What missions and what technologies could the Quad countries partner in utilising space to address climate change issues? Deputy
I would
Melroy.
love to take this one because NASA is already partnering with India and ISRO on our NISAR experiment, which is a synthetic aperture radar that is essentially mapping moisture for the purposes of agriculture, but also understanding and measuring some of the changes in moisture as a result of climate change. So I'm excited about this project. I had the opportunity to see the spacecraft out at the Jet Propulsion Laboratory about a month ago, and I can tell you it is going to be amazing to watch this in space. It's a great example of how we're better together because we're using 2 different frequencies developed, payloads developed by each different country, but they work together and amplify the quality of the data. So NASA is actually mapping out as a part of what we call the Earth Observatory Program to really work with Earth scientists around the world to pick those exact measurements that we're most interested in and to make sure that we're monitoring and measuring the things that are most important. But I think also to make sure that that data is transparently available and it's available in an equitable way. And that certainly at our most recent meetings with our international partners at the International Astronautical Congress, that was a big topic of discussion. I think there's a lot of interesting work to do there, particularly when it comes to data dissemination.
Enrico,
Ray, if I can just add to Pam's comments, if you look at the Quad, early in the establishment of the Quad and recent statements is about sharing of Earth observation data between our nations. And I think that cements, the importance of this data to really understand the health of our planet. And we recently had a panel with the G20 heads of space agencies, and this theme was there. You know, the problems, the opportunities we have are not isolated to one country, whether it's drought, whether it's bushfires or wildfires, whether it's, you know, adapting to climate change. These are common problems. There's always unique circumstances in each country, such as the eucalypt forests here in Australia. But the potential for collaboration is something, you know, we're certainly focused on, and would love to work alongside our partners on this panel and around the world. Because I think, again, back to the access to space, you know, the reason we know many of these challenges facing our planet is because of access to space.
Ray, can I also comment on that?
Please do.
Thank you very much. Well, I also would like to comment on sharing data. Satellite data is one of the key elements of the joint statement of the Quad dialogue. So, and in addition to that, I would like to elaborate on JAXA satellite that monitor atmospheric environment for tackling climate change. And about 12 years ago, in 2009, JAXA, together with government, has launched the Greenhouse Gases Observing Satellite. We call it GOSAT, as the world's first satellite dedicated to monitoring greenhouse gases such as carbon dioxide and methane. And 3 years ago, in 2018, GOSAT-2 was launched with an enhanced capability of observing carbon monoxide, CO, in addition to CO2 and CH4 for the emission estimation. So, and these two satellites have been contributing to addressing climate change by accumulating data on the global concentration of greenhouse gases for more than a decade, and have shown that the global atmospheric concentrations of carbon dioxide and methane have been increasing every year, accompanied by seasonal variation. And leveraging this cutting-edge GOSAT series, we will continue to support the country's efforts to reduce greenhouse gas emissions, to combat climate change under the Paris Agreement, using the global observation for monitoring the sources of greenhouse gases emissions, and also for estimating the emissions and their removal on a global scale. And I think, anyway, we would like to further collaborate with many countries in the world, and also contribute to the global climate change problem and issues. Thank you very much.
Thank you. Now, we've had a question come through for Deputy Melroy from Madeline in Moscow. China and Russia have signalled their intention to have an international lunar research station. Initially, it will be uncrewed, but ultimately it will see astronauts operating from this facility and extracting resources. To what extent can the Quad states work diplomatically to convince China and Russia to more closely collaborate on lunar exploration? And if they fail to do so, how might we manage disputes over territory and resources on the moon?
It's an excellent question, and I think that point about managing disputes is really at the heart of it. And we think that, you know, that the Artemis Accords is a first step towards the articulation of our values and our principles that we have going forward. We're actually very proud of the fact that we just initiated the point that it's time for us all to start talking about that. We hope and that China and Russia will understand the importance of having that dialogue and begin to publicly articulate what they think those important values are and the approach that should be taken. And that way we can have a global dialogue, and that's what's going to help us get to a place where we'll have a framework for dispute resolution. But everyone needs to start talking about it, and that's the most important thing.
Absolutely. Now, we've got a question from Priya in London. How can small states best exploit space? The example of the UAE and Australia as rising space powers might be a basis for other small, formerly non-space actors to consider opportunities in space. So looking at smaller actors, perhaps in the Indo-Pacific region, what are the possibilities for these states to best exploit and develop space capabilities?
Rae.
Please do.
Early in the discussion, we talked about, the renaissance in space that's come about from, the Moore's law applying to satellites and also sort of the reduction access space. So once many activities in space, used to be the preserve only of the world's major superpowers, that has changed. Commercial entities, they're not necessarily bound to jurisdiction, can innovate very quickly and get technologies into space because of those barriers have been reduced. Certainly Indo-Pacific, we always encourage collaboration and cooperation. I think strength in numbers will allow us to do some really interesting missions, particularly around Earth observation and others. But there, with the barriers coming down, the sort of market economics are playing. Whether it's developing technologies to and we've seen companies like Astroscale, companies from countries like Singapore working on technologies to clean up, the environment in space. And so I think there's just an innovative market that's very accepting, I think, of all nations to be space actors. And, Australia's had a long heritage in space, but, our strategy is built upon growing the industry. And I think that's being reflected in many nations around the world now.
Now, despite the increase in private investment into space and the broadening dual-use nature of space technology, there still remains a pivotal role for the government in space missions due to their scale and duration, cost, complexity. Also, the international policy issues associated with space are complex and often related to national security. How do you see the role of government in space missions changing in each of your countries?
Well, thank you very much. Well, as you pointed out, the role of the, space agencies are changing right now. That's true. But I think still there remains a great amount of, jobs to do for us. For example, the space agency should be the hub connecting everything. Everything means, of course, the government itself, and also the private sector, academia, and also international organizations such as the United Nations. And that's one role. The other role is to foster a space industry by in many ways, such as providing or sharing experiences, best practices, and exchange opinions. That will boost the private sector to start, at least. And that is because for the startups or space venture companies, the biggest hurdle is to start itself. Or access to space. That is the biggest hurdle for them. So that's what we can do or we can contribute to. And then I think still, but for example, space science, earth science, contribution to the global climate change and exploration, I think those matters should be done at least at the early stage by the space agencies. That's my understanding.
I'll hop in there. The role of government is, particularly here in Australia, is to create, as Dr. Yamakawa said, to nurture and foster the development of the industry. And that's, some of it may be private direct investment through grant or procurement programs in particular. And we've seen the success of some of the models in the US. But broader than that, it's providing a regulatory framework so these companies can operate. It's opening doors internationally, and often, it's appropriate for space agencies to work with other space agencies. It's creating confidence that there is a market, and it's providing direction. Where do we see the most credible opportunities for the sector to develop and grow. So that's at the Australian Space Agency. That's what we see our role is that broad range of things that facilitate the market. There's going to be investment in early research, as Dr. Yamakawa said, to get these companies off and running. But really then also find the point where we get out of the way. We have commercial companies as our customer, and that's what's going to sort of drive critical mass. And so, one of the earlier questions was about, is it just government investment into the long term versus with robotic and crewed missions versus, some of these international companies coming together. It's both. You need both, I think, for that sustainable presence. And we're in an inflection point. We've had tremendous human beings like Pam fly to space and do amazing things, but over 60 years on average, we've seen about 10 different human beings go to space, which is a tremendous feat and something that certainly has inspired me. But that's not enough of a critical mass to sort of grow market opportunities. And so we've got to sort of step now to a higher power curve. And that's what I think our agencies can help do.
Deputy Melroy.
Yeah, I think just great to hear the way my colleagues articulate this. I think I have a hearty and resounding yes to all of them. I think we are very aspirational. The administrator and I are for NASA, that we see that NASA is an engine to drive commercial development for sure. Excellent jobs, but also the benefits that come from space for those of us who live here on Earth. And so, yes, we do that by partnering, by funding, by encouraging, by nurturing, as Dr. Yamakawa said, through that startup, opening doors, as Mr. Palermo said, to go forward. But in addition to that, I think it's very important to remember that the fuel for the engine is exploration. It's doing the hard things. It's pushing ourselves to do things, whether it's in scientific exploration, something super challenging like a Mars sample return, an incredibly complex mission that we're planning with our European partners for the early 2030s, but will help inform where we would want to send a crewed mission, for example. So doing those really difficult things, and that is both scientific, but also trying to keep humans alive in this environment is incredibly challenging. And so those pushing ourselves to be aspirational and to do those very difficult things, that's the fuel. And then the engine runs, and the output we can hand off to our commercial partners. I think one of the most exciting things for us now is, we would, if the world were the same as it was 20 years ago, we would be wrestling to find the resources to continue to do the essential microgravity science that we do today on the International Space Station, that's helping us understand things like more efficient combustion engines and some of the key processes inside the human body to give us better insights for medicine. But we intend eventually to hand off low Earth orbit to commercial partners that will save us money and allow us to put the investment, more of that investment going forward, into expanding out into the solar system. If we had to continue to do everything all on our own, it would be very tough to find the resources to do that. So I'm excited by what I see as a virtuous cycle, but it can't keep going if we don't keep exploring.
Absolutely, well said. Mr. Palermo, how essential is human spaceflight to the future of our respective space programs? Is there a possibility that Australia could find ways to contribute astronauts to the human spaceflight programs of the Quad partners? Will I ever have a shot?
I see a future where we'll all have a shot eventually to fly to space. One of the key priority areas in our civil space strategy is access to space. And within access to space, which is an area we are mapping out right now, is the consideration of human space flight. I think there's tremendous potential for us to contribute to the community of human spaceflight. You know, initially, for example, we are supporting Israel's Gaganyaan human spaceflight mission, and we're going to learn a lot from our support of that mission. We've talked about our collaboration on the Artemis program, which I think over time might open opportunities as we contribute significantly more infrastructure than we are today. So we're thinking about this actively at the agency. What is the regulatory framework for human spaceflight in Australia is under consideration, and we think there's a huge opportunity to consider human space launch from our nation. We have amazing open ranges, amazing locations with amazing views that can support human spaceflight, and we have deep experience in and this was surprising for me, delightfully surprising when I came into the role, the depth of expertise we have in space medicine, life sciences. And that stems from our support of the participants in the Australian Antarctic Division, as well as support of remote communities. And so I think I see Australia having the potential to be a place where we could launch human space flights one day. I see us contributing our expertise in space medicine and life sciences to our partners. We'll continue to support missions through our deep space network and communications. And I think as we contribute more and more, I'm certainly hopeful we'll end up in a position that we can have an Australian astronaut program.
Chairman Sivan, I'd like to address a question to you now on space situational awareness. For the benefit of our audience, space situational awareness, or SSA, it refers to the process of keeping track of objects in orbit and predicting where they will be at any given time. Of course, this is key to maintaining a space traffic management system, avoiding collisions, but it's also crucial to ensuring secure access to space-based technologies. With the emergence of new space actors and with the large constellations of satellites, accumulation of space objects, including space debris, is likely to pose major challenges to undeterred access and sustainable use of outer space. This makes space situational awareness a crucial element for safe and sustainable space operations. How can Quad countries better collaborate to enhance space situational awareness?
Large number of satellites and other debris objects indeed pose significant challenges to future space operations. As the object population is expected to grow by many folds, safe operations in outer space will invariably involve continual awareness and assessment of space situation, transparent data sharing, a great deal of interagency coordination, mutual understanding amongst operators. No country can carry out comprehensive SSA in isolation without collaborating with others, because meaningful SSA requires a distributed network of sensors all across the globe. Under Squad framework, new observation facilities in Southern Hemisphere, Indo-Pacific Oceanic region can be established to leverage their unique geographical advantages in terms of coverage of orbital arcs of space objects, and the data can be shared among the member states through a suitable mechanism. Given the increase in the number of space objects in the coming years, we need to evolve a more sophisticated and standardized mechanism for exchange of conjunction alerts and associated information to enable effective mitigation of close approach threats. The Squad, the states can work in synergy towards.
So, Dr. Yamakawa, what other challenges do you see from the rise of mega constellations in low Earth orbit?
Well, thank you very much for the great and difficult question. Well, yes, I think the most important thing is transparency in space. It is very vital for the sustainable use of outer space. And so that means that we need for example, satellite information for our own satellite operations, and other space agencies also require satellite information or space debris information to operate their own satellites. So this means that we have to collaborate anyway. Otherwise, there will be some. I mean, of course, due to the heavy traffic, space traffic, there may be a good chance of collision of satellites or space debris. So anyway, the key is transparency, and the key is the sharing information of the satellite and space debris information.
Unfortunately, that's all we have time for today. I want to thank all 4 of our brilliant panellists for their contributions. Thank you so much. And thank you to our Sydney Dialogue audience for tuning in. A reminder that all our sessions will be available for catch-up on the website from next week. This particular session will also be streamed at the Bengaluru Tech Summit, BTS, which is Asia's largest technology event. The convergence of dates, themes and sessions between the BTS and the Sydney Dialogue speaks to deepening bilateral ties between Australia and India, and our shared interests in working with like-minded countries to shape the norms and rules underpinning emerging technologies, including space technology. Don't forget, you can continue the conversation on Twitter using the hashtag TSD2021. Thanks for joining us today, and we hope to see you again in the next session.